Section 5B, using the distance formula to find the distance between 2 points. Alright, so here we have a picture. Now if you're looking for distance of a line, and the line happens to be vertical or horizontal, well, that's pretty nice, because really all we have to do is see how long it is. 2 units. It's 2 units in length. However, if we have one that is not vertical or horizontal, then we have a little bit more work to do. Now, the distance formula is a modification of the Pythagorean theorem, because I can take this and create a right triangle by making a horizontal line and a vertical line that come together and would connect the 2 dots, the endpoints. If I have vertical and horizontal, I know that I can easily figure out the length of each one. That unit is 1 unit high, that side is 1 unit high. This side is, I believe, 8 units long. And I'm looking for this. Well, this is side C. That's the longest side, it's the hypotenuse. So the Pythagorean theorem would say 1 squared plus 8 squared would equal that hypotenuse squared. So we have 1 plus 64, which equals c squared. In other words, c squared equals 65. So if I root both sides, I have approximately 8.1, and you can leave it as root 65 or 8.1, but that is the approximate answer. And later on, the questions will be specific to say, write a simplified radical or round to a tenth. Okay, so that is how we can do it if we have a picture. But if we don't have a picture, then we need to use the coordinates, just like midpoint. And that's what we'll talk about next. In 21, we do not have a picture. Now we could graph it and use that picture to create our answer, or we could just use the distance formula. Now, this one says round our answer to the nearest tenth. So keep that in mind when we get to the end. So we have 2 coordinates, 2 endpoints. The distance formula is just like Pythagorean. So we would take the difference now, instead of adding them and dividing by 2, we're going to take the x values, we're going to find their difference. So this is the difference of the x values, these 2. I take that difference and I square it. I want to add it to the y values, 0 minus 1 squared. Those 2 squared will equal the hypotenuse squared. And I want to call it distance, or I could write c, your choice. But this was where it kind of looks like Pythagorean. The difference, though, is the distance formula is solved for d, so you would root both sides in the end, which is what we've already done. But when we calculate this out, this part right here alone, you're basically looking for the root of, and 3 minus a negative 4 is 3 plus 4, so 7 squared. Negative 1, or 0 minus 1 is negative 1, so plus a negative 1 squared. So 49, and negative 1 squared is a positive 1, rooted, so root of 50. Now this one, we would simplify the root if they asked for it. We would round to the nearest tenth if they asked for it. This one asks to round to the nearest tenth, so if I actually take the root, I'll get 7.1. Now let's try that again with one slight change, and that is where they ask us to give an answer that's, in this case here, simplified radical. So if we look at 27, the same idea has to be considered. We don't have a picture, we're going to use the formula. And the formula is to take the difference in the x values. Remember, midpoint is sum, or average of x values. This is difference of. So we take 7 minus a negative 3. We take that difference and we square it. That's one part of the Pythagorean theorem. And now we take the y values, find the difference there, so negative 8 minus 6, and square that. And that will equal the hypotenuse squared, but the distance formula has that side solved already, so we're going to have to root both sides at some point. So this is the official formula. 7 minus a negative is plus, so we have 10 squared, which is 100, plus negative 14 quantity squared, which is 196, rooted. Well, add them together, we have 296. Now here they want the answer simplified, not just taking the root and getting a decimal. Well, I know that 2 goes into all of it 148 times. I know 148 is divisible by 2 74 times, and 74 is divisible by 2 37 times, and that's prime. So I can take out a pair, which gives me 2. And on the inside, I still have 2 times 37, which is 74. So this would be considered a finished simplified answer.